All right, welcome functions folks to the first video of Unit 1 on polynomial functions and equations. Um, Short video. This first few days of this chapter, which is actually Chapter 3, Unit 1, Chapter 3 and 4, the first few days are investigations where you're going to be doing lots of stuff in class with your classmates, and so that's the case today. But I do want making this video to show you a couple of things. The 3-minute review is to do a bit of business about finite differences, and we'll talk about what finite differences are in a second. There's one from the textbook and a sheet that you want to fill out, which is actually the first thing that we're learning about polynomial functions is using this finite differences. And the sheet looks something like that. And I will take it up in a second, but I want to show you before you get into it that you can, if you choose, certainly you're welcome to figure out all this stuff on your own. You know, you just fill it, take x is -1 and fill it in there, and then fill in the table, and the differences are, you know, differences between adjacent values of y, and you calculate the differences, and you look for patterns and find the conclusion. This is a pain, especially when it ends up being a long expression for y. And so I'm going to show you a couple of tricks on the TI-83. You're welcome to use these tricks or not. That's up to you. First of all, we could use this graph. We've done some graphs, and notice I've put in -3x squared minus 4x plus 1, and you know I can hit graph, and the tables not, or the window settings aren't very nice, but that doesn't matter. What I can do then is I can use the trace key to help me find values for y. So for instance, trace, and then notice it gives me 0, 1, so I know that 0 and then this goes 1, but I wanted -3. If I hit trace and then I put in -3, even though it's not on the graph, I can find it there. Put in -14, and so on. Put in -2 and -1 and so on. In fact, I could use the table feature there as well. However, that's not the real thing that I want to show you. I want to show you how to use the lists to do this sort of thing, because this is pretty slick. So hit stat and then edit. And you might have a whole bunch of crud in here. If you do have a whole bunch of crud, you go up into the top, you highlight the list value, and you press clear and enter, and then that'll wipe out that list. Notice this list is exactly the way that we wanted it, so I'm going to leave it like this. And notice here I want this to be the y values, and I need to type in this equation. Now what's weird is it doesn't know what x is. If I were to put an x here, it wouldn't know what I'm talking about, because what I really want, I just wanted to take the value that's in list 1 and put it in for x. And so that's what I do. Second function, list 1. I'm going to square that. -4, not x, but 4 times, put times in there, times list 1 plus 1. And notice that I'm up in the top here. This is the whole list is going to be equal to this. And I press enter, and bam, it does all of those at one time. And I could just copy them all from my calculator. And so on. I'm not going to do them all for you. You can do them. So, well, how is that easier than doing the graph? Well, it's not, but watch this. This is even more slick, because now I have to go through and I do the differences. And the differences can be a bit of a pain as well, right? Subtracting or adding or whatever. The calculator will do this for you as well. Notice I'm going to get -3, and I'm up in the top here. I'm not in one of the cells. I'm up in the top, list 3, and I'm going to set it to be equal to the differences. I can actually get it to calculate the differences. And how I do that is second function list, second function stat, which is the list, and that gives me all the list names, but I want to go to this ops, over to ops, and then down to change in list, differences, change in list. And notice it's still waiting for me. I need to tell list 3 is the change in which list? Well, it's the change in list 2. This is going to be the first differences, and I get them there. 11 and 5 and -1 and 7, and I suppose I could have calculated those, and so on. Notice that this right away tells me that this function isn't linear. Well, it's quadratic, right? But what this means is as soon as I see that the first differences aren't constant, I know it's not linear. And I can keep going if I wanted to, and that's what this whole lesson is about, is on what differences tell us about a polynomial function in general. So I'm going to get list 4 to be the change in list 3. Second function, list, over to ops, change in list. Second function, list 3. List 4 is the change in list 3, and bam, and then it's minus 6 each time. And remember what that tells me. It tells me that when the second differences, this is the first differences, this is the second differences, when the second difference is constant, that it's quadratic, right? And this sheet is about asking you to talk about polynomial functions in general. So fill out the rest of the page. I'll take it up in just a second. You're welcome to use the graphing calculators or not. That's up to you. Okay, here comes the my answers. You can check them with yours. All the differences there, and I use the calculator. I don't know if you used them or not. Now notice that if you haven't tried this, shame on you for looking at the answers before trying them. You should stop it and actually do this. It's good for the soul. It's good for your math soul to do this sort of thing. But the overall conclusions is that if we do the differences n times, and the nth one is constant, that tells me the polynomial is of degree n. So the highest term value would be n. And so notice that allows me to go from a table. Hopefully you figured this out, that the fourth differences are constant, which means that it's a fourth degree polynomial, which means that the right side looks something like that. Notice the bonus here, find the equation of this. Well, you'd have to find A, B, C, D, and E. Well, notice that this gives you a hint right here. When I put in x is 0 into this, I get an output of 0. So what do I know automatically? I know that E is equal to 0, and then all I have to do is find those other 4. And I'm going to leave it up to you, but I'll give you a hint. If you've taken data management, that you should know how to do this already, believe it or not. Okay, and the lesson is an investigation. So this is what you're doing in class with your partners, and some homework, and it's talking about the nature of a polynomial function versus a non-polynomial function. So we said all of these things were polynomial functions. Well, what made them polynomial functions? That's what this exploration is all about, and you have an FAQ, and have fun with that. We'll talk to you soon. Bye-bye.